If I asked you to sort the items below into groups, my different shapes, you might sort them in a variety of different ways. Some people might group them by color, put all the blue ones together. Some people might put all the red ones together. You could sort them by triangle versus square. So a collection of objects like that is a set. So sets can be infinite or finite. Infinite means it basically continues forever and ever. You couldn't list out the items within it. Versus finite, you could write them all down. It stops at some point. The items in your set are called elements. So if I have a set of colors in the American flag, sets are contained within those squiggly braces and the elements are inside of them. So the set of colors in the American flag would be written the set of the colors red, white, and blue. To show that an item is an element of a set or inside it, we use the symbol that kind of looks like a curvy uppercase E a little bit. So I could say that red is an element of that set of flag colors. To say an item's not inside of a set, not an element of it, we use that same symbol with a little slash through it. So purple is not an element of that set of colors. And we can also name sets with capital letters. I could name that set of flag colors F, and that way I wouldn't have to keep writing out the entire thing all the time. I could just go, hey, purple's not an element of set F. There's also notation called set builder notation, which uses a variable to represent some general element of your set. So if you have the set of all natural numbers between 1 and 40, and you don't want to list them all out, 2, 3, 4, 5, 6, 7, 8, etc., you can say, I want all of the numbers X, and then the vertical line stands for basically such that your variable meets those requirements. So that's a shorter way to write out the set of all natural numbers between 1 and 40. And just by the way, between, when we're talking about it, means strictly between. It doesn't include the start and end. So between 1 and 40 would be 2 up to 39. So let's look at some sets. First, we're going to decide if each is infinite or finite. So if I look at set B, it's an infinite set. It continues on forever and ever. It's increasing your denominator by 1, so it contained 1/5, 1/6, 1/7, and so on and so forth without ever ending. Now, if I wanted to determine whether or not 8's the element of my set, well, it doesn't follow my pattern. I'd have 1/8, but not 8 itself. So 8 is not an element of set B. On our second set, it's written in set builder notation. So it says W such that we have the numbers W that are odd numbers. So it's basically the set of all odd numbers, which makes it infinite because it's 1, 3, 5, 7, continues on forever and ever and ever. If we're considering whether or not 8 is in there, again, 8 is not an element of that set. I'm going to go ahead and name it with a letter so I don't have to rewrite the words that represent it, because 8's not an odd number. Let's look at part C. So again, we're looking at set builder notation. This is a set of all of our numbers X such that they are natural numbers between 1 and 8. So natural numbers, quick reminder, are your positive whole numbers. So this is going to be a finite set because that's just the numbers 2, 3, 4, 5, 6, 7. It stops, I can list them out, it ends. So it's a finite set instead of infinite. And again, if we're talking about between does not include 1 and 8. So 8 is not an element of this set. So let's take some set notation and write out the elements that belong to our specified set. So if we have the set of A, such that A is an animal shown below, well, I've got a chicken, rabbit, and a dog. So those would be the elements in that set. If we have X, such that X is a natural number less than 8, that means the numbers greater than 0 that are positive whole numbers. So 1, 2, 3, 4, 5, 6, 7, and it's less than 8, so it's not going to include 8. Some additional properties of sets: you can have sets that actually don't contain anything, and that's called your empty set. So notation-wise, you can do 2 squiggly braces with nothing inside, or you might have seen the little 0 with a slash through it. Sometimes it's used to represent that an equation has no solution. It's the empty solution set. Also, sets can be contained within one another. and that idea is called a subset. So if every element in set A, so 1, 2, 3, is contained within set B, which they are, then that means A is a subset of B. And notation-wise, it's that little sideways U with the line under it, which means the line under it means it's a proper subset. They're not exactly the same. So think of it as like A being contained within B, like those little Russian nesting dolls. And our last property is that two sets are equal to each other if they contain the exact same elements. The order does not matter. Okay, so let's look at these sets and see whether or not each statement is true or false. If we're looking at A, we're basically asking, is Q a subset of U? So is every element within Q contained within set U? Well, if we go up and find set Q, we've got 3 and 9. We want to see if those elements are inside U. They are. Therefore, Q is a subset of set U. On B, we want to see if R is equal to Q. That means they have to contain the exact same elements. So if you look at R, it's got 9 and 3 in it, and Q is 3 and 9. Those are the exact same numbers, even though they're in different orders, so they have the same elements, and that's a true statement. If you look at C, it's another subset. We want to see if set S is contained within set U. So if you look at set S, find everything inside of it in set U, that makes it a subset. But we don't have 20 inside of set U, so that means it is not a subset. On D, it's kind of a little bit of a brain bender, because what this statement is saying is that U is not a subset of S, so U is not contained inside of set S. So let's see if it is. So if we find everything in set U, that's in set S, that's in set S, 15 is in set S, 21 is not contained within set S, so that means it is true that U is not a subset of S. If we look at this situation, Amy says that the set containing 9 is an element of Q. Luis disagrees and says that 9 is an element of Q. Which student do we agree with and why? So pause and ponder for a second, maybe. This is one of those notation things that I really just wanted to point out here. I can say that 9 is an element of Q because 9 is a number that's inside set Q. Amy's statement is actually not true because she's saying that there is another set nested inside of Q that contains 9. So really, the set containing 9 is not inside of set Q. For that to be a true statement, we'd need a set that looks like what I just wrote down. You can perform operations with sets by doing things like intersecting them or joining them together with a union. So an intersection of two sets is all the elements that are shared in the overlap between two sets. So if I have set A and set B, and let's say set A has 1 and 2 inside of it, and set B has 2 and 3 inside of it, since they both share 2, the intersection would be just the set containing 2. You can have sets that don't have any shared elements or overlap. Those are called disjoint sets. And a union of two sets is the elements that belong in either set or could be in both of them. So notation for it's a U, kind of U for union. So if you basically dump all the elements in A and B together, if I have those, it'd be the set containing 1, 2, and 3. So first I'm finding the intersection of these two sets, which is the items that they share. So if I look at what they share, the only thing they have in their overlap is 4. So my intersection is just the set containing that shared element 4. B is the union of those two sets instead. So that's everything in my first set and my second set joined together. So that would be 2, 3, 4, 5, and 6. Set containing those would be my union. And you don't have to write 4 twice, even though it appears in both sets. And yes, that's supposed to be either. My pen didn't pick up my R, apparently, when I wrote it. If I wanted to give two disjoint sets, those would be sets that don't share any elements. So if I was to do set A being the set containing 1, 2, 3, and set B just containing 4, those two sets would be disjoint. If I tried to do the intersection of them, I'd have my empty set, nothing inside.